Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Berk, and I do data engineering and machine learning at Databricks. And today I'm joined by my wonderful and lovely co-host,
Ben Wilson. I do quarterly planning at Databricks.
And today we have a very special guest. Her name is Brooke, and she is one of the faces of Databricks. She got her undergraduate in Chinese and then her master's in distributed ML from UCLA. And then right after graduating school, she joined Databricks as an ML solutions consultant and is currently the director of Databricks' ML practice. Now, in her free time, she writes books about Spark, co-hosts the Data Brew podcast, which we just learned doesn't exist anymore, teaches courses, and also speaks Mandarin. And so, Brooke, why did you switch from Chinese to distributed ML?
So it actually wasn't a switch. I was actually studying computer science in my undergraduate, but I studied abroad in China, not through UCLA. It was a scholarship from the Chinese government. And when I came back, UCLA said we wouldn't take any of your credits. And because of my GPA, I had guaranteed admittance to the master's program. I'd already taken all the computer science and the math classes at that point. I just didn't take any of the physics or electrical engineering courses. And one of the best lessons my dad ever taught me is the answer is always no unless you ask. So I asked, hey, I obviously know my computer science skills, my math skills, would you still do guaranteed admittance for me? Even if I don't technically have a computer science degree, I can get my Chinese degree though in a quarter. And they said, yeah, no problem. And so I could effectively do 2 undergraduates in 5 years or 1 undergraduate, 1 master's in 5 years. And that was kind of a no-brainer.
That's super interesting. All right, first, going back to your dad's comment, do you think it's better to ask for permission or just do it and ask for forgiveness? I mean, in this case, you have to ask to enter a master's program, probably.
But. Yeah, I think that guidance is a little bit different. The answer is always no unless you ask, of there is a policy and there's no way you can get around it unless you are to ask. So don't always treat no at face value. That's different than asking for forgiveness rather than for permission, because that means there is a way around it.
Yeah. Okay. Good clarification.
Or no policy.
Exactly. Yeah, just one quick clarification. Data Brew is on hiatus. It will return. Just timeline TBD.
Right. Excuse me. It is coming back very, very soon. So today we were chatting a little bit before we kicked off the recording about what we wanted to talk about. We were initially going to talk about managing, and the beauty of this podcast is it's very free form. So we can essentially see where the conversation goes and talk about whatever we want. And so what we're going to kick it off with is the concept of scoping projects. I know this is one of Ben's favorite things to discuss because it's so hard and so important. And so, Brooke, if you're put into this position of scoping a project, what are the things you look for from the outset? And just how do you think about it?
So the first thing is to validate whether or not there is a use case. So whenever account teams come to me saying hey, we need to scope a customer engagement, I actually have a form of these are the things you need to tell me before I walk into a customer conversation. What is the use case? Are there any known escalations? Are there any timelines that I need to be aware of? And then I typically like to have a quick 15-minute internal call just to make sure I get as much of the basic information from them so I can focus the time with the customer on addressing any questions that I have at that point and just regurgitating the information, just making sure we're all on the same page. In terms of scoping, customers are all over the place right now. Everybody wants to say they want to do Gen AI, and a lot of them don't understand ML. And so the first step is to take a step back of what is the business problem you're trying to achieve? And let's align on success criteria. Right now, we're getting tons of requests of I want to build a model that can beat GPT-4. Can you help us with that? And we'll take a step back and say all right, what are the problems you're facing? Is it that you want to have control over the model? Are you having issues with cost? Is it that you want to fine tune the model? Why do you want to do this? So take a step back, figure out what is the ultimate driver. Because like I said, so many people just want to say, we're doing our thing. We're building our own company ABC GPT. Too many letters there, but figuring out what is the actual business problem they're trying to solve, why they want to solve it. And then oftentimes there's some politics at play and they will not outright tell you what those politics are. And so that's where having that information from the account team is super helpful, just so you can understand what is their incentive, what is their motivation. Sometimes the motivation is just hey, we have extra budget at the end of the year and we want to experiment with something. It's not actually mission critical, just they have budget and they want to see if it works. Other times it's our team is going to get dissolved if we don't show value by the end of the year. So it's always helpful to figure out what stage of a customer you're walking into.
What is your thoughts on whether LLM based ML is it worth the hype basically? Because I know that Databricks is investing super heavily. There's a lot of use cases, there's a lot of revenue, but is it sort of an internet where there's going to be a bubble that will burst, or is it actually going to provide value from the outset?
I think it's just a question of what stage in the hype cycle is it. I think there is immense value. There's also immense risk. And so, for example, like the use cases that we're seeing the most success in are augmenting customer call specialists. So many customers, rightfully so, are hesitant to have anything customer facing. Like we've all seen the example, like the Chevrolet dealership, like recommending Ford F-150s. But instead, what we're seeing for like customer call specialists is instead of starting off with something to completely replace the human call specialist, it's recommending the next best response for that human specialist. And so with one of our customers, we had found an overall 20% reduction in time to resolve a customer query, as well as 15% increased upsell opportunities and overall a much happier customer. It's like, that's a great example of you're able to save costs and you're able to make your customers more happy and you're actually able to sell more with that increased upsell opportunity.
Yeah, I mean, from the few customers that I talk to now, it's usually evaluating our API designs. The ones that I see that seem to be things that people are pushing to production are exactly that as well. It's like I think a lot of fear that people talk about is like, oh, it's going to replace our job, or it's going to take over this thing, and you hear that from like junior software engineers sometimes. Like somebody's going to create one of these tools that's going to write JavaScript for me, and then I'm going to be out of a job. It's like, nah, like we all use these things as like the successful application of these is in augmentation, and it's information retrieval at its core. Like, how can I get to the correct information as fast as possible without having to, sift through tons of potentially irrelevant information?
Yeah, I'm not a fan of the job replacement argument because what is it, like the 1800s, 98% of humans were farmers. Of like, oh no, we're automating agriculture. Like we have these great new tools. Like people aren't going to have jobs, and like that's not the case. 98% of people are not unemployed right now. And so, like, sure, some jobs will be eliminated and or greatly reduced, but there will be new jobs that are being created. And so I think that's the side that people are not realizing is just how many new jobs this is creating as well.
Yeah, something that I heard of that blew my mind recently are all the companies that are starting up for the gig market for Gen AI, where companies, and I'm not going to name names of who they are, but most of the big ones that are building the next gen or the cutting edge state of the art stuff, you can't do validation testing yourself. Like you do your first training iteration, data science team is going to be doing that, or a QA team internally is going to be doing that. Then you go to fine tuning, and then you need to find out, are there risks associated with usage of this thing that we just trained from scratch? Your internal teams are not going to have enough time to do that. It's just too much data. So you create a bunch of training sets or validation sets, and then hire a company that basically does mechanical Turk operations. It's like, hey, let's get 10,000 people around the world who are all either experts or generalists in these topics and have them tell us if this is bad, and then get the results. And it's a whole new economy that's starting up. I didn't know how many, I know a couple of people that are doing that on the side right now, and look at the number of jobs that are coming in each day from these services. And it's in the tens of thousands of projects to be done, and they're burned through within 24 hours.
Yeah. Wait, okay. So another question for actually both of you. What do you think of the closed source versus open source model debate? Like, what is there going to be a winner? Is it a time and a place for each? What are your guys' thoughts?
Go ahead first, Ben.
I wanted to defer to you first because I have a bunch of bias here. So I think it extends to the same principle of just general software. Um, there's benefits and risks to both. So in a closed source system, you might not know what's going on or how it's made, or you can't see what's going on, but you're paying somebody to maintain that for you. And you have a finger to point to and a vice to tighten when things aren't going right. So that company that's maintaining that as a service is very motivated to correct that action for you, or correct that fault with it, or build a feature for you for something. And then in open source, it's kind of opened up like, hey, you want something, build it and give it to the rest of the world for everybody to use. It's up to open source maintainers to control whether that should be included, whether that should be released, and whether it's safe and useful. Or you can just create your own projects and push it out there, and maybe people will use it. Maybe it'll pick up traction. But we're talking about something that costs so much money to build. The difference between closed source and open source is who's building it, why are they building it, and how much money are they putting behind it. You talk about. Go ahead.
So I think we are talking about closed versus open models, because we're not talking about open source. A lot of these models, like, they're not releasing the training code, they're not releasing the training data. And if you follow the Llama 2 style license, they are restricting who can use these models. Like, a core tenet of open source is anybody can use this. But with the Llama 2 style license, it's, if you have more than 700 million monthly active users, you are not allowed to use unless you receive explicit permission, yada, yada. And so I think it's really a question of closed versus open models. Ben, to your point you're talking about earlier in terms of having a finger to point, how would that differ if someone is providing an open model as a REST endpoint, for example?
If a company is offering an open model as a REST endpoint.
Yeah, like Databricks does, Amazon does.
I think that becomes much more of, if we're offering a paid service with that, we're highly motivated to respond to requests or if issues come up, because we're making money off of that thing. But in the case of Meta, they release this model and say, hey, you can use this for whatever you want. You can fine tune it, but we're not going to show you how the spaghetti's made here. They're not motivated to fix anything with that. And they look at their licensing agreement, and there's a lot of caveats in that of like, hey, we're not guaranteeing that this isn't going to, give you instructions on how to build homemade bombs. Use at your own caution. I think the motivation for the open model process for ensuring that it's of a high quality, it's more reputation based than money based.
My personal thought on the open versus closed model is it's expensive to be using these massive models if you're actually trying to put use cases into production. And for a lot of customers, they care about low latency, high throughput, low cost. And so we are starting to see a trend of customers wanting to build much, much smaller models. So like, I was chatting with a customer yesterday, like they want to build a series of models that are less than 1 billion parameters actually for a highly specialized use case because they need it in terms of the low latency. And so that's when we're like, you're not going to get a closed source model or a proprietary, I'll just call it proprietary model. You're not going to get a proprietary model off the shelf that's going to be able to perform your specialized task at the size that you're looking for. And so that's one of the divides I see. I'm also seeing a lot of financial services companies in particular being interested in pre-training models from scratch entirely. They don't even want to use open source models because they are concerned about the data that went into it and making sure that they have high fidelity information. They have high fidelity data, and they know all of the data that went into it as part of regulatory requirements. So for most of our customers, starting off with a REST endpoint, whether or not it's a proprietary or an open model, like that's the part that makes sense to start with, like demonstrate proof of concept, proof of value, benchmark it, and then figure out what are your gaps. Is it a gap on uh, quality? Is it a gap on performance metrics? And then figure out which one makes sense for you. I think there's a place for both. I don't think they're mutually exclusive.
Got it. So sort of a function of use case maturity, organization maturity, and then like regulatory requirements.
Yeah.
Cool. Yeah, so that's super interesting because Databricks has been investing heavily in the like the open source side or the open model side. But I think Brooke, your prior question about it seemed like you were hinting at, is there really a difference between a closed and an open model if you're not open sourcing the training code and the training data? Because Databricks theoretically, let's not talk about Databricks, the owner of the organization or owner of the model is theoretically still responsible for its performance, right? So it's almost as if it's closed source. Is that what you were hinting at?
What do you mean by the owner of the model?
Like the publishing organization that created the model, given it's not really open to complete retraining or complete modification, you can fine tune it. Um, it seems like it's still on the onus of the organizing party to give it, even though there aren't official SLAs, it's the onus of the organization to maintain it, ensure quality, theoretically ensure you don't give building bomb instructions. Is that what you were hinting at, or am I off base?
I wasn't quite hinting there, but with open models, you can grab them at any point in time and you know they're not going to change. Like you pulled into your organization, you fine-tuned it, it's not going to change. Like there have been plenty of studies that have shown that for the same endpoint, the GPT 3.5 and 4 models changed answers over time with having all of the other factor set.
Got it.
And so like that's one of the challenges if you don't own the model and the infrastructure of the underlying model could be changing and you don't think it should be changing. So like you run all of your tests and like, okay, great, it passes. But now if the same endpoint that you've been hitting suddenly gives you different answers, like how do you control for that? And so there is an element of control as well that you get from the open models that you don't get from any proprietary models because it's up to the provider ultimately.
Yeah, and this is almost like a Gen AI specific issue when we're talking about model as a service sort of infrastructure, because it really is an economy of scale when you talk about like what are the solutions. If Brooke, if you and I were going to create a company that was offering XGBoost models that we would retrain for these specific use cases, we could version lock those, retrain them every day, and host 10,000 of them on a suite of REST endpoints, and we would probably be paying maybe $50,000 a month in cloud computing costs for hosting that, because they're super cheap, they're lightweight. We don't have special infrastructure. We can run those on some optimized CPU or something, and it'd probably be fine. When we talk about Gen AI model, that hardware is stupidly expensive to run these things. When you talk about the infrastructure required to respond to the level, like the volumes that OpenAI is dealing with how many requests are coming in per second to their mainframe. You need a very bespoke implementation where you can only host so many of those versions of these models until you're like, oh, we need 5 more data centers. Each of them are $40 billion a piece. So it starts to become economically infeasible to like version lock and say, well, I want the version from 7 weeks ago, and I'm going to use that for the next 6 months. OpenAI can't do that.
Nor would they want to, maybe.
And even more so, like, yes, it's all expensive, but there's just a global scarcity of resources as well. It's like even if you want to, you wouldn't be able to acquire the GPUs necessary.
Right. Okay, so Brooke, shifting back to the scoping conversation, what is the biggest, or what are some things that make projects fail from the scoping phase?
Not establishing success criteria. So that's where like customers are saying like we want GPT-4 quality models. We will instead reframe it as, all right, we are working off of an open model. Like, we'll figure out which one is most suitable for your use case. Our guarantee will be if we fine tune that model, it will outperform the base model that we fine tune for your domain. Because customers, like, they say, yes, we want to fine tune it on our data set because we want to perform better in that domain, but then they want to evaluate it on like Hello Swag or these other open benchmarks that have nothing to do with their domain. And so, like, one of the open problems right now is that there aren't industry standard benchmarks for like HLS, for FINS, for financial services that everybody agrees on and uses. And so that's what makes the evaluation part so hard, because they'll tell you like, hey, we've got the data for fine tuning, but they won't necessarily have like, what are these golden standard responses that we're looking for the evaluation. And so that's where it gets really tricky in terms of establishing success. Like, all right, we fine-tuned the model. Is it a success that completed? Or is it a success that it actually performed well in this evaluation data set? And so, like, making sure everybody's in alignment and just educating the team as well, because like this is new for most organizations. And this is where just really working with the business side, and like they love actually being educated as part of this, like be at the cutting edge, if you will. But yeah, it's really establishing success criteria and success metrics from the beginning.
Have you found that over the years since the hype started with Gen AI, that the people that you're talking to who are now doing this stuff has shifted at all?
We're talking more to lines of business rather than to data science teams, actually. And so that's what's been really interesting. Like, I have this business problem. Like, I am a marketing company, and this is my problem. Or I am like the CMO, and this is the problem that I need to solve. Versus working with a data science team. So yeah, it's definitely shifted who we're having the conversations with. We're definitely having conversations more with the executive team as well too, because they're providing board updates. The board wants to know what their Gen AI strategy is, as opposed to like, let me help you build out your MLOps framework for your data science team to help you productionize models more quickly.
Yeah, we're seeing the same thing on the MLflow open source side. The people that we're interacting with now, I don't know, we just noticed it over the last couple of months. We're getting a lot more questions from people that, like, this is definitely not a data scientist asking this question. And you look them up on LinkedIn, you're like, yeah, it's like a staff software engineer at this company. They build apps. And now they're using MLflow, and they're asking, like, why is this designed this way? Or why do I have to specify these things? Like, this isn't a model.
Mm-hmm.
This is effectively a script that I'm defining. I'm using LangChain. Like, why do I have to do this stuff? And it's just interesting to me how that would shift now that, if we talk about people that are writing code in industry, 5 years ago, people writing data science related stuff, building models, training models, putting them out there for usage, it's probably less than 5% of people touching keyboards. And now with Gen AI craze, we're now opening this up to 90-something% of people that are titled as, computer science focused in a company. Do you think that that's going to continue into the future? And where do you think that's going to land, say, 5 years from now?
All right, I'm not going to make any prediction 5 years out. But I think that was partly born out of necessity. There's a shortage of data scientists. We've known that for years, even before the Gen AI craze. But separately, to build a RAG application, you don't need to be a data scientist to do that. For fine-tuning and pre-training, you absolutely do, like understanding like what epochs are, learning rates, like hyperparameters, all of that. But for just putting together a basic RAG application, like, yeah, that's something a software engineer could totally do. Just take some courses and then try building it. You don't need to understand the inner workings of deep learning to be able to put together a RAG application. So 5 years out, I think everybody's going to be more Gen AI literate. That's my only prediction for the future, Ben.
Question for both of you, just from personal preference, what type of stakeholder do you like talking to? Is it the software engineer, the ML engineer, the CTO, the CMO? What's your favorite discussion to have?
Brooke?
All right, I'll go first this time, Ben. CTO. They are the ones that can call the shots. They have the budget. They are technical. So those are generally my favorite folks because they are the executive stakeholder for whatever that project may be. So like even if the CMO wants to do a project, the CTO is still going to be aware of it. So that's my preference. Ben, curious to hear yours though.
I wish I had something different to say. The only thing I would add on to exactly what you just said, because that's the person that knows like what's going on and who's going to resource and staff. My second favorite people to talk to, this might sound stupid, but the actual owner of the project, which most of the time back when I was doing similar stuff to you in the field at Databricks, it's usually nobody who's touching the keyboard to write any implementation. It's like the marketing team or sales team, whoever at a company that actually is going to be using this model. And the reason I like talking to them so much is because they provide faster insight into what actually needs to get built than anybody who's building the thing. A lot of times at companies, the people building it, they didn't even talk to the people that are going to be using this. So they have this mental model of like, we're going to produce predictions, we're going to write it to a table, and this team will just use it. And you talk to the team, and they're like, yeah, we don't even have access to whatever they're talking about. I don't know what this is. It's like, okay, let's think about this a little bit.
Yeah, I always give that example with like healthcare in particular, because like doctors are naturally skeptical of any ML models. And it's like, who cares if you built the best model to predict cancer, whatever it may be, if doctors aren't going to use it? It's like you definitely have to work hand in hand with the person who would be the end consumer.
So one of the reasons that I'm asking that question is I am put on a lot of projects similar to what Brooke's team does, but typically more in the platform or data engineering space. And the first call that we always have is getting that political context, determining who the key stakeholders are, what's the success criteria, and we try to get it in writing just to like cover our bases. I was wondering, Brooke, if you could sort of elaborate on. So you said the lack of success criteria make projects fail, but from a political or like organization specific context, what have you seen makes projects fail more than other traits, let's say, that is about customer inefficiency or like lack of communication between teams that's external to your project?
A lot of times it's not thinking about how do we get this to production. I'd say it's not super political for showing proof of value, proof of concept. Like everybody knows that's early stages, but it's all right. Now we want to get this into production. And realizing, wow, it's actually going to be really expensive if we want to be using GPT-4 for all of these thousands of requests that we're going to be anticipating every hour, every day, whatever it may be. And so planning as well. It's like the traditional data science problem. A data scientist will build a model. The data scientist will not be the one that productionizes that model. Like you need somebody from the ML engineering side or the DevOps team to help productionize it, and then who's going to monitor it. And so what we're seeing is proof of concept, proof of value. That's easy to get everybody on board. It's a relatively low time investment, relatively low cost investment to get to that phase. But it's what are the gaps to getting into production? So for a lot of customers, it's security of, all right, we've done this on a subset of data that everybody in the company has access to. If we actually want to roll this out for all of the use cases that we have, not just like the HR employee docs that everybody has access to, what other data sets can we get? Have we done our due diligence there? Red teaming, testing it out, cost, monitoring. There's just so many potential gaps along the way for production that most use cases that we're seeing are still internal use cases. So they might be in production, but they're just not externally facing.
Got it. Ben, so you work internally in Databricks and don't typically interface with customers. Do you see similar issues with productionizing as a big bottleneck, or is that typically handled well?
I mean, I interface with customers, usually through engineering support tickets. Um, like we broke something or we didn't think the use case through. So the vast majority of things that we get are during production deployment, where they've already done all that planning homework. They know what they're doing. So it's the more sophisticated side of like our customer base, or in the open source community. Like these are people who are finding issues with like, hey, you guys have this API to build this container, and it doesn't allow me to configure my integrated OAuth. Like, what the hell? Like, why isn't this supported? So it's like, oh, that's going on the roadmap. Sorry, we'll fix that for you. So we don't get a lot of questions or issues with people that are in that formative stage. Like sometimes you'll get questions about like, hey, this API is broken for tracking, or for like registering my model. This is messed up. That's early phase stuff, and that's more functionality of the core product. We don't talk use cases with them, but sometimes we come on and talk to customers when we're getting ready to deploy something new, or like a new major feature. We'll meet with 20, 30 customers and get to hear what cool stuff they're doing. And the interesting thing for me is those were the customers, like the people that I talk to in these calls now, is the ones that I never talked to when I was in the field. Because they don't need help. They're capable of reading through the source code, figuring it out. And it's usually really, really top-notch engineering groups. But they're the ones that are like, yeah, we're going to test this out. We're going to break this and tell you how it's broken so that you can improve it. During those calls, sometimes you hear about like what they're trying to do, and you see some really interesting things that people are doing. Like, oh, yeah, there's this model. Yeah, we got it trained. It's great. Data science team did an awesome job. Now we're integrating it into our app platform, and this, like, we are having problems with the size of the container that's deployed here. Like, why are you including like the JVM in this? Like, we'll fix that, make that a little bit lighter for you. But then they'll talk about what the actual use case is and how they're doing controls and how they're doing like failovers. Like, hey, if this thing starts losing its mind for this use case, we have a fallback that we can do for our app. Or we also have, like, we're taking everything that's being generated, we're submitting trace events from every request that's made, and that's going into a real-time database that we're continuously monitoring and checking. So you see like very sophisticated things in that space.
Okay. I think I'm following. Another question, Brooke. So, all right, we've exited the scoping and planning phase. How do you think about delivery, specifically balancing prototyping with just building something?
Oh, this is a good question. This came up this week. For example, like we have a new feature. We do not know if it will fully address the customer's need, but we know that we could always fall back to the do-it-yourself RAG implementation as an example. And so generally, we try to time-bound that as well as add some buffer in. So for example, like when we scope engagements, if we realistically think it's going to take 15 days, we'll put 20 days there. We have no idea what issues we're going to hit, just need a little bit of padding time. And so like if there's a new experimental feature that we think could drastically improve the efficiency for the overall customer, we might time bound that, like, all right, we've got 3 or 4 days to do this. If to either address, are there any major gaps? If there are major gaps, we abandon right away and we share that feedback with either the product team, whoever it may be. If there are not major gaps, then we make the product team aware of like, hey, we are planning to do this. Please let us know if there's any issues, anything we should be aware of. And oftentimes, if we do plan to go ahead with that approach, they will invest the additional engineering resources to get an early customer in. And it's a great working relationship as well, too, because engineering needs that early feedback from customers. So they don't go down a rabbit hole of like a single mind track of this is the approach that we want to take. When they start seeing customers actually adopting it and realizing how many different ways they plan to be using it or different things that they didn't think needed to be supported. So it's this great relationship because engineering also knows us. We're internal to Databricks. They know we know what we're doing with the product. And so at least there's a level of trust, also a level of reciprocation. Like generally we will have seen that the PRD early on. We'll have done some early dog fooding. So by the time we start using it for our customer, we know what we are doing. We just don't know the limitations of the product or the limitations for that given use case. So yeah, definitely need to do some time bounding. The worst ones, though, are when customers want to use LLMs for migrations. That's the one that I run away from. And this was all of the craze last year that of people thinking like LLMs are this magic bullet for migrations. And what we had told them, like, you are welcome to try experimenting with it. We don't think it's going to work for you. I'll tell you why in a second. But you are going to scope a 100% migration effort. We will add a 15% buffer. So your overall like net proposal is larger than if you didn't want to do it, because we need that fallback plan of the traditional migration approach if the LM doesn't work out. And typically it won't work for me. There's 3 types of migrations. There's direct code migration, which is often not what customers want to do. They often want to do a modernization. And it's like LLMs are great at the code translation. They're not great at modernization. Like, try taking some legacy code and converting it to the medallion architecture on Databricks. Like, there's no out-of-the-box LLM that will do that for you. So that kind of rules out the second one of modernization, which is what most customers want to do. And so where we're seeing LLMs being most successful for migration-related use cases are either asking questions about the legacy code or generating documentation or generating test cases. And so it's not this magic bullet that customers all thought it would be. And when we explain it to them like that, they're like, actually, yeah, we realize that this is not the right use case. Does that answer your question, Michael? I feel like I went on a bit of a tangent there.
Yes, it 100% answered the question. So basically, add some buffer and time bound.
Exactly.
Cool. Yeah, it's funny you say that about migrations, though. My team does a lot of migrations. It might be from a different cloud system into Databricks or between Databricks tooling or things like that. And we typically don't support things outside of Databricks. But yeah, the amount of times that we've just tried to throw an LLM at stuff and it just breaks immediately. Yeah, it's unfortunate. But as you're pointing out, being in a information retrieval system and helping you understand the systems, that's where LLMs seem to be really, really good. And I use GPT-4 every day to like answer basic questions about how do I use PyTest fixtures or how do I do this or that. Like, if it's well documented, specifically in the Spark space, like Spark has been around for years, it usually has reasonable solutions to simple problems. So it allows you to be a generalist a lot faster than other systems.
There's some tactical stuff with code, though, that I can 100% tell you that almost every engineer at Databricks uses LLMs for this particular use case. Aside from what you mentioned, Brooke, about docs, yeah, definitely. Doc strings, it's exceptional at doing that. And that just saved you 15 minutes for each function or method that you're documenting. But when you're unsure of sufficiently complex implementations, if you're doing something that is reducing the ability for somebody who didn't write it to grok what you're doing, it's really great. So if you have prototype code that you're like, hey, I'm just banging out this solution, I wrote this function or this method in this class, and just asking one of these models, like, is this readable? Can this be refactored to maximize readability and understandability or testability? Where they were a year ago was pretty garbage. Like GPT 3.5, not that great at that. More recent builds of GPT-4 are exceptional at doing that, where it'll take overly complex implementations and break it down into testable components. We're like, hey, you're doing something here that by rewriting this internal method that you have in this other method, externalize that or make it static and make this a little bit simpler. And you look at what it comes up with and you're like, man, thanks, buddy. It's just like the ultimate, code rubber duck that's just sitting there next to you and is ready to give you advice. And I find that 9 times out of 10, with that targeted use of those tools for a software engineer, it's really good because it removes that mental model that you've already built. You have context on it. You know what this thing's doing that you just built, and it seems simple to you. But asking it and prompting it in that way, like, hey, can a junior engineer understand what I just wrote here?
So I've got a question for you, Ben. So if somebody is studying computer science or learning how to program from scratch, like they're brand new to it, do you think they should go through kind of the traditional approach of not using any of these augmented tools like Copilot? Or do you think that they should try to do whatever or do you think that they should learn how to program leveraging these tools from the get-go?
I think learning to code and computer science are not directly related to one another. So learning computer science in an undergrad or grad degree,
Mm-hmm.
that is absolutely never going to go away. Understanding fundamentals of algorithms and logic and how to construct, like, what are the components that make computer systems work and information architecture and stuff.
Mm-hmm.
That's so key and critical to understand that stuff. And if you don't have that background and you get into software development, you're going to have a rough time. You're going to learn it the hard way. And it's going to be really painful. But for coding, I see coding, like actually sitting down and writing code, as more of a trade skill that requires deep knowledge of the fundamentals of like how these things work. But it's more of a like practice till you get good sort of thing, and you just grow as you get experience in this and have people providing mentorship to you to correct you. That's the whole reason for code reviews. And having like a tech lead that's answering your questions. I see that Gen AI shortens that process, even for a new developer. And even though people that I've talked to are kind of worried about that, they're like, oh, we shouldn't have junior engineers use these tools because they're never going to learn the basics. I'm like, I don't actually see that. I think it's like them having a TL that they can ask questions to, no matter how stupid they think they are. And there's no judgment. And they can just get an answer and kind of see. What I don't think is ever going to be successful in software engineering in industry is somebody who's doing copy pasta output responses from a tool without checking it. I've seen PRs in MLflow, like open source contributors where I'm like, this, thank you, GPT-4. This function that you wrote does not solve the problem because it can't load the entire code base and see context.
Yeah.
It's like, hey, you're using this API that's actually not designed for this. Or, hey, let's not use this private API that there's no guarantee that this is going to stay in this functionality. If we change that, now this implementation is broken. We don't want this linkage here. So that's dangerous. And that it puts a little bit more sort of workload on maintainers of repositories, whether it's internal or external, like open source or closed source. But that's more of a process thing. Like, you just follow up the person and be like, hey, nah, let's not do this. And this is why. Please change this. And hopefully that prompts that person to be like, all right, I need to actually do some work here.
I like your distinction between computer science and programming. One thing that we continually struggle with is, as part of our interview process, we have a coding assignment. And we know, like, it's not a proctored assignment. We know that people have access to these tools. We ask on our policy that they do not use any form of assistance while doing the coding exam. I guess, given that kind of mindset, Ben, since people are going to be using these assistants as part of their jobs, what are your thoughts on, for coding assignment interviews, of seeing how productive they are with these tools versus without using any tools?
I think even with the honor system, good luck on keeping people honest about that. I don't think that should be an expectation. And I think stuff like take-home coding assignments for job interviews are going to be a thing of the past, because there's no way you can guarantee that person created that, or that they even understand what it is that is being asked. Because you can take the question and the context of that, paste it into a chat template and get a response that's probably pretty darn correct. And all they have to then do is just execute it and be like, did I get the right answers that this thing is expecting? All right, on to the next question. So on our side, we don't do stuff like that. It's all live.
Mhm.
And not necessarily like, hey, open up an IDE and implement this algorithm. Although there are certain interviews that do that. But it's more being able to discuss an implementation in pseudocode, because you don't care if somebody can write flawless code. Like nobody does that for their job anyway. We have all of these tools to help us craft a good solution that can be merged into a code base. It's more of understanding the why.
Mhm.
Why was this built this way? Or why did you choose to build it this way? What are the downsides? Like, hey, what happens if you're using this list iterator here, and what happens if the data increases by a million fold? What does that do to this algorithm?
Mhm.
And if they can't think through that or don't understand it, there's like nothing happens. This is resilient. Like, all right, and then that's when I open up like a screen share and write the actual code for them and say, let's try it. And then you see that it just crashes the Python REPL, and you're like, here
Mhm.
we go. Or, hey, we hit the recursion limit in Python with this implementation because we're iterating over nested dictionaries that are 1,500 levels deep. So I think, to answer your question directly, I think it's going to change, and it has to change.
Mhm.
But it's on the onus of the hiring manager now to find somebody to rewrite that interview process.
Yeah, we intentionally have an open-ended question so that it's not a yes or no. And as part of the following text screen, we do ask pointed questions about the code, asking about the approach to try to guard against it. But of course, there's no way to really ensure that they were even the ones that wrote the code in the first place as well. So it's a challenge for all hiring managers, but we think so far it's working. But yeah, definitely always a challenge.
Question
Yeah,
off
I
of
think it's
that.
harder on my side when you're talking about like, hey, design a system that provides a REST API to this sort of service and get this working. Like, use this database type, and this is the data structure, and create a schema that you can insert data into the CRUD operations on a table,
Mhm.
and then create an interface for that. You could probably use an open model that's not particularly well trained, and it would still kind of grok how to do that. So yeah, that's why we're doing this live sort of thing.
Mhm.
So I was just in a wedding in Baja, Mexico, and as we are all like awkwardly standing around sipping a margarita, AI comes up because my job is like data science or whatever, and everybody's like interested in the field, and a lot of people who are data or like ML adjacent, so in the data space of some sort, are really interested in entering that field. So, Brooke, your team is the best of the best in theory, and they're quite good from what I've seen. Lots of them have PhDs. Lots of them have many, many years of experience building distributed systems and complex ML implementations. How would you recommend someone start entering the AI space if they have a data skill set?
If they have a skill set, okay. That's an interesting question, and it's one where like I feel like a bit of a hypocrite with, because for my team, because Databricks right now is such a hot company, like we have our pick of the litter of candidates that are applying, and so like the bar to get hired today is much higher than the bar to get hired a few years back. Like all of my tenured team members will joke, myself included, if I were applying to Databricks today, like with the same resume I had back then, it wouldn't have been picked up, just because of how high the bar is right now. And so, like, if somebody's brand new to, if they're brand new to AI, like, even if they have like 20 years of software engineering experience and they're fantastic at that, like, they're so far behind on the AI side that it's hard to get hired into a data science team. And so, my recommendation for folks who have data skills but not AI skills is see how they can use AI to make their team or their function more AI driven. Um, and so like that could be if you're like, let's say, even if you're not in a tech company or like you're let's say you don't even have data skills, like you're an environmental scientist, let's say, and you want to get into AI. Wait, do you have an environmental science degree?
Yeah, I failed out of computer science, so I studied environmental science.
I did not know that. So yeah, let's say you have an environmental science degree, like Michael, and you do want to get into AI. It's thinking, what are a cool project that you could be using AI for? For example, like recognizing sounds of like bird calls, as an example. And so that way you're able to still leverage your expertise in a domain, but then build up a new skill set so that eventually you can then transition fully into AI if that's the way that you want to go. But I always try to look for use cases where somebody's able to contribute their skills while still developing other skills. Because if they're not able to contribute their existing skills, they're just like a junior entry level person that needs to be trained up from scratch. And so that's where like they wouldn't be a good fit for my team, but like I eventually like try to bring AI into your existing team or function. That way you're still able to be productive and you're building up that skill set throughout.
Crystal clear. Yeah, if you can sort of leverage your existing situation as a jumping off point and start incorporating new things, like the 0 to 1 shift is often difficult. So if you slowly incorporate, that makes a lot of sense.
And it's also easier to do within the company you're at than trying to jump to go to another company to make that switch, because you already have the connections, you know how the company operates, you have that trust. And oftentimes companies are willing to make concessions to keep top talent. And so they will potentially find a way to like, hey, I want to balance like my day job with this, but I want to effectively be like an intern to the data science team or whatever it may be as well. So yeah, I definitely recommend trying to do it within your existing role, because if you're trying to do 0 to 1, it would be hard to land a job at another company with that sole focus on AI with limited AI skills.
You just explained my career path. That's exactly how I got into data science. We were doing factory yield analysis, which is with me and the people that were on that team. This is, 15, 16 something years ago. Maybe older than that. It was like 18 years ago. But we were so annoyed with the manual process of going through and doing things in spreadsheets of like, hey, I need to find outliers in this column of data, and it's got 4 billion rows in it.
Mm-hmm.
And just applying like basic statistical formulas onto that iteratively. Like, oh, this data set has 15,000 columns, and we have to write a macro that's going through and basically identifying rows that are, basically SPC rules on this data. And none of us knew programming or how to do this the right way. We were using like VBA scripts and stuff. And eventually we're like, there's got to be a better way. Let's take some classes and just see if there's a way to do this. And that's when we all learned Python the first time. And we're like, oh, there's these like stats modules out there that we can use. And then we started learning more and saying, isn't this what the model stuff is? Like this machine learning stuff, like we can just use like a logistic regression model and see what happens. We trained it and we're like, hang on, this just saved us 34 person hours per week by just this one model. What else can we do? And 3 years later, we had a suite of over 100 models that we're running in production every day that were automating all of this stuff that we hated doing. And we were saying like, oh, yield just went up 37% on this line because of all this stuff automating what we couldn't get to before. And yeah, management, we didn't even ask. Like management just said, you're all now like the data science team. Like just do this. And we're like, okay. And they're like, hire 15 more people to make more of this.
Mm-hmm. But then exactly those 15 more people that you hire, they all have to have the skills that you all had already picked up. So it's one where it feels like the bar keeps getting higher and higher.
Yeah.
Brooke, do you prefer people with that sort of Ben background where it's homegrown and they've learned it over time, or do you prefer the PhD in distributed ML?
So one thing I pride myself in is that I think we only have 3 people on a team of 14 with the same degree. And like, of course, that degree is computer science. Everybody else has a distinct degree. So like we do have an environmental science degree on the team. Actually, we've got philosophy degrees on the team, stats, math. And so I do think there is something to be said for some level of continued studies, but that's not a substitute for hands-on practical experience as well. It's like there's a balance between the two. I will say the average level of education on the team is between a master's and a PhD. Most of the team has masters. There's one postdoc on the team, or one team member who did actually 2 postdocs. So generally, we look for folks who have some form of grad studies because ML is not commonly taught at the undergrad level. Undergrad level, like they might take one ML class, if that. There are some schools like Stanford, Berkeley, like those are schools that actually have proper ML courses for undergrads. Most of them don't. Most of the computer science programs are teaching very, I don't want to say antiquated concepts, but just they're not teaching the things that industry needs. They're not teaching cloud skills. They're not teaching Git. They're not teaching ML. And so that's where I will generally err for somebody who has a master's or a PhD, so they have those ML skills as well as a few years of industry experience. Because that way they'll have picked up the things that they needed to pick up for industry, but still have that strong foundational understanding of ML. We actually only have one team member who only has an undergrad degree.
Interesting. Yeah, I remember in undergrad, I spent 3 weeks on Perceptron in one class, and I was like, come on, guys.
I remember my NLP class in undergrad was using Lisp and all using overhead slides. Like they did not change in 30 years.
Man. Yeah, and just out of curiosity, do you know why that is? Because it seems like academia lags behind industry in terms of tooling, which makes sense. You don't use, I don't know, Git, Docker, clouds as much. But why don't they just like ask?
There's this brain drain from academia to industry right now. Industry is so lucrative that top academics are just being pulled into industry. And I think it's also the kind of divide of it's hard to, so like schools like Stanford and Berkeley, like Databricks co-founders are also professors at Stanford and Berkeley. Like they have that flexibility to be able to keep professors on. Like Matei still teaches courses. I think Ali's been on a bit of a hiatus for quite some time now. But like Jan, one of the other co-founders, like he's a professor at Berkeley. And so schools that are more connected to tech, I think have a better understanding of like that balance of professors spending time in industry, and they can feed that back into the classroom. But typically that's only at the grad level to be able to get that cutting edge, more seminar style courses rather than at the undergrad. Like it takes a lot of work to update a course syllabus. I remember at UCLA it took 2 years to approve a new course. And so like by the time you approve a new course in this space, like it's already going to be out of date. Like I remember when I went through my computer science degree, they said the half-life on a computer science degree is 7 years. And it's much shorter than all of the other fields. And I think that half-life time is continuing to decrease. I don't know if I'd call it 5 years now. But yeah, it's hard to keep up with industry, particularly when professors don't have that opportunity. I remember, I believe UCLA had a limit of like only on Fridays could professors do advising for industry. And so with that limited feedback loop, it's hard to kind of get that information flowing both ways. And so like Databricks does have a University Alliance program where we do share some content with universities. We give them free access to Databricks, but that's not an entire semester long course. Like that is a lot of work to build and to maintain. So I think there's some fundamental issues going on there, but hopefully other schools start to pick things up. UCLA now has, I think, 2 undergrad ML courses, but yeah, most of it's at the grad level.
Got it. Okay, one final question for you. What are the traits of a top data scientist on your team?
Grit, curiosity, and collaboration. And those are all things you can't teach in school. So like you go to school to learn the foundations. All of those other skills are ones that you can't learn from just reading through textbooks. And so for me, collaboration is one of the most important ones of like, how well do you work with other team members? How well do you work cross-functionally? because I do not care how brilliant an individual is if they're not able to lift up the rest of the team and the people around them. So yeah, that's collaboration. Curiosity. It's doesn't matter what your prior experience has been if you don't have the potential and the drive to continue to learn new things. And so like we saw that with the shift to Gen AI. I only had one person on my team with serious NLP chops prior to the Gen AI craze, and now the entire team is delivering on Gen AI engagements. And it's like if they didn't have that curiosity and drive, and we only hired people for past experience without that curiosity or that potential, like they wouldn't have made that transformation. And grit, it's being willing to not only work smart but also work hard, and like wanting to work on tough and challenging projects. And I would say that that was something that Databricks culture very much hired for early on, is assessing out grit. And like that of course changes over time. Like I'd say those are probably my 3 key hiring principles.
Super well said. On collaboration, can you elaborate though? What does that mean? Like, is it communication? Is it teaching and mentoring? What is the actual activity of collaboration?
Collaboration could be like, hey, I'm struggling with something. Does anybody have a second pair of eyes? Like team members jumping on, like, yeah, I'll help you out. Other ones like volunteering information back, like, hey, I struggled with this. Like, here's my hacky workaround for all these lane chain issues. It's also identifying like these are areas that aren't working well in Databricks. Like, hey, our field team isn't as conversant in Gen AI as we need them to be. Like, what are ways that we can upskill them and contribute our knowledge back? And so like one way is like we could do a rotation, like they work on a professional services engagement that we oversee. We get some temporary additional bandwidth. We're also helping to transfer our knowledge back to them. So it's really trying to find ways that are win-win for everyone and just doing the right thing for the company, as opposed to solely focusing like, I want to be the owner of this thing. I don't want anybody else to touch it. So yeah, it's really focusing like what's the right thing for the company, what's the right thing for the customer, and not trying to overly focus on the I. It's more about the we.
So it's more like context-aware knowledge transfer.
It's more than just knowledge transfer though. Like it is actively seeking out to do things with other team members as well. So for example, like co-presenting at a conference, like that's one where I'll always tell the team, like it doesn't detract from you if you have a co-presenter. What it means is you have somebody else that you can bounce ideas off of, somebody else that could take over the presentation should you fall ill as well. Like it's overall less work on you, and you get the same amount of credit whether you present solo or you present as a pair. And so it's looking for folks who want to work with other team members and they see the value from it. And like that's something that I evaluate in the interview process. If they just say they're trying to take credit for others' work. If they say we too much, then I'll ask like, all right, what exactly was your particular role? So like it might be like I was the tech lead and we accomplished blank. And like that's what I love to see, is like giving the team the credit for that. And so like with the team, I always encourage other team members, and I love seeing like they give each other shout outs of like, thank you for helping me figure this out. Like you saved me 10 hours of thorny debugging issues for a problem I would have never figured out the solution had you not helped out. So it's really trying to help out other team members and doing the right thing without necessarily regard to your own reward or credit.
That also really shows with the interactions that we get with your team on our side. Not only so you can always tell when it's somebody who works for you, when there's something from the field coming into our team channel, because there's always a reproducible code snippet that actually has import statements at the top and everything. It's like, this is a fully functional thing to reproduce this issue. And then there'll be a series of not like, hey, this is broken, but more like, I expect this API to do X. It does Y. Can it do X plus Y? And here's the justification for it. And usually when we read that, when we read a report like that, you can always see the Slack history because it's really short. It's like 4 or 5 back and forths. And at the end, it's usually, here's a link to a PR that I just filed to fix this for you, instead of the other, group of reports that we get where it's like, hey, this doesn't work. And you're like, what doesn't work? I tried doing this thing. Like, can you give me a repro? Or, hey, this threw an exception. Like, can you give me the stack trace? It's like, it's clear that your team thinks about these things from how to solve a problem perspective, as well as you can also tell that they've probably discussed this internally amongst themselves. They're like, hey, I tried that as well. Yeah, it's totally broken. Like, let's tell engineering. It's a special culture that you've helped build on that team.
Thank you. Yeah, it is something that I do intentionally foster. So like for my team, I typically will cap the amount of time that they spend on professional services engagements about 32 hours a week. And so with the remaining 8 hours, like that's all hands one-on-one, but the rest of the time is spent working with R&D. And so like with the product champions program that we have internally, working closely with a dedicated Eng team. And if not, that's testing out the new features. Because we are going to be using them on projects, and it is way easier if we catch these issues early on. We're able to provide constructive feedback than once it's already gone GA if we need to make like a breaking change to an API. So yeah, definitely something that we intentionally do, and that's when we're like, the sum is greater than, what's the phrase? The whole is greater than the sum of its parts. Of working together with engineering to try to make the product better, rather than trying to say like, I built this awesome thing that's a workaround for all of this.
Yeah.
Like, isn't this great? It's like, no, the right solution is first principles. Let's see how we can make the product better and work with R&D on that.
And we greatly appreciate it.
That resonates like crazy. I'll see what we can do. Awesome. So we are at time. I will quickly summarize. Today we started the conversation talking about scoping. Brooke's tips is start off with a use case checklist and ensure that there's an actual real world value that can be provided by the solution. And then once that's affirmed, you can enter a conversation, typically a call, where you can discuss success criteria. A couple common pitfalls of planning is not getting that success criteria ironed out, and then also not thinking about moving the POC into production. On the proprietary versus open model side, it's typically a function of organization maturity, use case maturity, and then also regulatory risk. So choosing between whether it's going to be an open model or a closed model, you can sort of think along those three axes. And then if you have data skills and you want to move into AI, try to incorporate your existing use cases to actually leverage some AI in some form. And typically in your current organization, you'll have more leeway than trying to enter a position without experience. And finally, top data scientists have grit, curiosity, and collaboration. So, Brooke, if people want to learn more about you, your team, maybe potential roles on the team, where should they go?
Databricks.com/careers.
Cool.
We're always hiring.
All right. Well, until next time, it's been Michael Berk and my co-host,
Ben Wilson.
and have a good day, everyone.
We'll catch you next time.